different mindset. It takes a lot of patience, but at the same time, you understand that the excitement, the potential, the unique aspect of what you're doing is what motivates you.
Well, Dave, we're very excited for that long journey and to get that eventual data too, but we'll be patient. Thanks for being on the show today.
Glad to be here.
Well, Franklin had a chance to actually learn more about this incredible mission when he traveled to California to talk to the team.
We're here at the Jet Propulsion Laboratory in Pasadena, California, where an engineering team built and tested the Europa Clipper spacecraft for its nearly 10-year mission to Jupiter's moon, Europa. And today I'm here with Kobe Boykins, who is the chief engineer of that team. How you doing, Kobe?
I'm doing well. Thank you for having me.
Can you talk to me about the challenges of engineering a spacecraft such as Europa Clipper for a mission this long?
Yeah, well, I mean, I think we'd start with the time period isn't really the driver, right? In a mission like Europa Clipper, it's really the thermal environment that you're going to have to live through as you fly through interstellar space. You're going closer to the sun. You're getting hot, you're going further away from the sun. In this case, you're going out to the Jovian system. You're more than 5 times the distance of the sun-Earth distance when you're out there. And we are a solar-powered mission. So it's really about how do you get enough energy to keep yourself warm? And how do you make sure that the materials that we're using, all of the pieces of the spacecraft will last for the duration that we want this mission to last for. And the other thing we have is we have a very interesting environment because around the Jovian system, you get radiation, a large dose of radiation, and we have to make sure that we can survive that as well.
You have solar arrays that are probably the biggest that have ever been used for a planetary mission.
That's correct.
And then when you talk about the radiation, this spacecraft is built like a tank. Can you talk about that?
Yeah, we'll talk about, we'll separate those two, right?
Okay.
The first thing is talking about a solar-powered mission. So yes, we have a solar-powered mission, and we're really, one of the requirements was to make 700 watts at Europa, right? 700 watts, think about that. You know, the lights that are, illuminating us in here probably make more than 700 watts.
Right.
And we're using that power to do this amazing science investigation of this moon in the Jovian system. So you're going to these 2 extremes of temperature, and you have to have that structure survive, right? And you can imagine something that's glued together and not making it fall apart. Okay, so that's a struggle. And that's just to get the power. And then we have this radiation. As you said, we're more like a tank. We have this thing we call the vault. And the vault holds our electronics. Inside that vault, what we're doing is we're protecting from these high energy particles, right? What we nominally call radiation, and that getting into and causing single event phenomena or changes in our electronics, where we get, there's ones and zeros, right? All computers are ones and zeros. And you could get one of those ones and zeros to be 1, 1 or 0, 0. That would be bad.
Right.
And so we want to make sure that that doesn't happen. So we have this really thick aluminum structure that protects us from that environment, and that reduces the total amount of radiation our electronics have to see. And that's inside this thing we call the vault. And that's what makes this thing look like a tank. And we actually have things that we call mini vaults that are on the outside that protect other pieces of electronics that couldn't live within the vault itself.
So talk to us a little bit about the environmental testing that the Europa Clipper had to go through to get prepared for this launch.
Oh, that's a fantastically good question. So in terms of environmental testing, let's sort of back up a little bit, right? One of the things that we like to talk about here at the Jet Propulsion Laboratory is the shake and bake, right? So we shake the spacecraft, we simulate the launch environment, and then we bake the spacecraft. We simulate the cold of deep space, or we simulate the hot of going toward the sun. And we have a unique facility here, which is we have a solar simulator, and we can actually increase the density, the power density of a sun, so we can actually give that energy to the spacecraft. And we can simulate being in space in that way. And so we do that kind of testing. We do an acoustic test where we actually shout at the spacecraft with big speakers, make sure that the launch environment is fully encompassed. And so then we understand, okay, we can launch, we're gonna be safe. And then we have to do one of these other pieces, which we don't do at the full spacecraft level, but in this mission we have a lot of radiation, as we talked about. And so one of the things we'll do is we'll do a radiation-induced outgassing test. And what does that mean to you? Nothing. But what does it mean to a spacecraft? Well, if you take a piece of plastic or a piece of material, it doesn't even matter what it is, it will, as it gets hit with high energy particles, it will outgas products. And because we're going to look for habitability around Europa, one of the things we want to make sure is what comes off the spacecraft is a known commodity.
Okay.
We don't want to go and see like hydrocarbons coming off of our spacecraft and go, ooh, we found hydrocarbons at Europa. We want to make sure we understand those constituents that are coming off. So a lot of the testing we did was put it in a radiation environment and see what happens to these materials. So a lot of materials testing. The other thing is we need to make sure that things that charge, what we call dielectrics, plastics, if you will, that will build up charge, they don't actually hurt our spacecraft. So you can imagine taking like a piece of plastic and hitting it with high energy particles and it holds those charge. Just like when you take a balloon and rub it against your hair and stick it up against the wall,
right,
or you zap your friend when it's a little dry outside, right? We're looking for things that do that, these high energy discharges, thousands of volts that can come back into the spacecraft. We protect in some ways, we filter some of that, and some of it we just take those hits, but we try to reduce that by protecting those sensitive pieces of dielectric material, making sure that they don't hurt our spacecraft.
Joining us now is the Europa Clipper Deputy Science Manager, Trina Ray. And Trina, I understand that, like Dave, this isn't your first foray into a Jupiter or the Jovian system.
This is very true. I've worked at JPL for 35 years. My very first job at JPL was on the Voyager project, Neptune Encounter. And then I worked Voyager, Galileo, Cassini for decades, and now Clipper. So I've worked every outer planet's flagship mission that JPL has ever flown.
I'm sorry, I'm just a little awestruck because it's just amazing the kind of work you guys do. As I was talking to Dave about the patience that you have to have and everything else. But, you know, Kobe was talking to Franklin about how complex this mission is. And it begs the question, like, how do you decide on Europa? What makes it a candidate worthy of such challenges?
Yeah, well, going back to those missions, as Dave said, Voyager really showed all of us how interesting the surface of Europa is, with all these cracks and ridges and, these jumbled terrain. And then Galileo comes along and they have the magnetometer data that gives you that hint that perhaps there's something interesting going on underneath the surface. And, our best guess right now is that there's an ocean underneath the surface of Europa. So there's this ice shell, just absolutely young, very few craters, really fascinating ice geology happening. Then underneath it is this ocean of liquid water that's filled with chemistry and energy. And Europa is sort of this original ocean world. And NASA decided pretty quick that they wanted to send a mission to an ocean world. And NASA was pretty quick to say, okay, Europa's the one.
Well, it's so interesting. So you identify this ocean, but like, how do you, are there instruments out there, like you go to the instrument store and you go, I need to check out an ocean, I need to check out some crags, and you just put it together. How do you determine which instruments you're going to include on a mission like this?
So that's actually a pretty tricky question, Blair. So one of the things that NASA does is NASA asks for advice every decade. They go out to the National Academy of Sciences and the National Resource Center. No, it's not Research Council.
Yeah.
And they say every decade, please give us advice about where we should send missions in the next decade. And scientists, planetary scientists, gather. It takes them a year. They all produce reports. They talk to each other. And then in the end comes a decadal study. And the decadal study is a recommendation from the community to NASA as to which missions to fly. And Europa Clipper has been at the top of that for about 3 decadal mission reports now. One of them got the mission started, and then the last one said, yes, you should still go.
Well, that's an interesting process all on its own. It's kind of like the Hall of Fame. You have some nominees each year that don't make it, and then you finally get the selection. So this is almost like almost a first ballot Hall of Fame mission for NASA. That's awesome. Now, considering all that, once you've decided that mission, you load it up with these instruments. Tell me about your favorite instrument that you're most excited about for Europa Clipper.
So my favorite instrument on this mission is the ice-penetrating radar, which is the Reason instrument. This is the first time we're flying an ice-penetrating radar to the outer solar system. And whenever you fly an instrument for the first time, you have the opportunity to have sort of the most dramatic delta in your knowledge. And so that is the instrument that I am really excited about.
Now I'm excited about it, which is awesome. We'll look forward to that data in about 6 years. It'll be great. We'll have a party.
Absolutely.
Awesome. Thanks so much, Trina, for being on the show.
You're welcome. Thank you.
Well, Franklin enjoyed talking with Kobe so much that interview is probably still taking place. Let's join that conversation, still in progress.
So you talk about the environmental testing or the shake and bake that you talked about, but you're also incorporating many instruments that are going to be used to collect data around Europa. Were there any challenges in incorporating this into the spacecraft?
Yeah, well, I mean, let's just talk from the first level, right? We're flying with 9 science investigations, and we have a 10th one that we do with radio science. So this is a huge science suite. Just having 9 science investigations trying to do the same thing around Europa, not the same science, but looking at certain pairs, just figuring out where everything needs to point.
Simultaneously
becomes an issue, right? And now you add in a radar system that wants to be it's on a solar array. And the solar array wants to point at the sun, but when we get to Europa, it wants to have the radar look at the surface. You have instruments that want to have bore sights that look exactly at a certain location so we can get very good high-resolution images of the surface. You have thermal imagers that want to look at the whole surface of Europa and see the thermal environment. And so that becomes one of the problems. The other thing about this particular mission is that we have a magnetometer, right? What's a magnetometer? It looks for magnetic fields. And one of the ways that we actually identified an ocean around Europa in the past with the Galileo spacecraft and Voyager was with a magnetometer. So we have this very, very sensitive magnetometer that literally paper and the way it's rolled when they make paper can magnetize the paper, and we can sense that. And so we even had to change the paper that we were using in our clean room to make sure that we didn't have a problem where we would actually hurt our instrumentation. So everything that comes into the clean room gets demagnetized, all the instrumentation is always rechecked. You can imagine how this affects the team of people, right? All the electronics, all the cables, all the wires have to be made in a way that keeps that magnetization down so that our spacecraft isn't so noisy that we see our spacecraft and not the Jovian system, in this case, what's going on with Europa.
I do know that there is an instrument that will be able to look and penetrate through the ice to see what's under it. Is that correct?
That's correct. It's called Reason. Reason's our RF instrument, our radio instrument, our radio frequency instrument, and our radar. At a high level, what Reason's trying to do is tell us how thick the ice is, how thick the water underneath that ice is, and if there's any subsurface water trapped within the ice. That might actually capture microorganisms or anything from the subsurface. Now, we're not looking for that in this particular mission. You're really looking for some really major things. Chemistry, energy, right, and water.
Okay.
Right, these 3 pillars come together to make the story that you could be a habitable world.
Yeah.
Right, and so if we can show those 3 things, we get a much more broad story about what's going on in this beautiful icy moon around Jupiter.
Now, the Europa Clipper is about a 12,000-pound spacecraft. It takes a lot of energy to get that spacecraft into space.
Yes, sir.
Are you using something like a slingshot to get this to Jupiter, or is it a straight shot?
So no, we are using a gravity assist trajectory. And so this is called Mars-Earth gravity assist. So we go out around Mars, and then we come back around Earth, and we use those 2 gravity wells to actually give us velocity and help us point in the right direction. And then 5.9 years later, after launch, we'll actually start slowing the spacecraft down so it will fall into the Jovian system and get into this very highly elliptic orbit that will have us encounter Europa. So we're actually orbiting Jupiter, and we're encountering Europa 49 times to get the science. Some of that's about managing how much radiation we get. Some of it about getting deeper flybys that get you closer to the surface so you can get better imagery or better RF signals. And some of it's just about how all these science investigations work together. So you need different altitudes of flyby. Our closest flyby to the surface is about 25 kilometers.
Yeah, you know, I stick to miles. I saw 16 miles.
Something like that.
Yeah. That's pretty close.
That's pretty close, right? When you think about it, it's a lot closer than you want it to be. It would be a little freaky if you were flying that, but it's a robotic mission, so we can push it a little bit.
Sounds like a very interesting mission. Honestly, I think I could talk to you about this for 2 hours.
Yeah, we could do it.
Yeah, we can absolutely do that. Kobe, thanks for being on the show today, and we look forward to the data from Europa Clipper in about 6 years.
That's correct, in about 6 years.
Good luck to you and your team.
Thank you so much.
We look forward to a successful launch and a great mission.
Thank you very much. I'm looking forward to it myself.
I know you are.
Thanks.
Joining us now is Europa Clipper project staff scientist Kate Kraft from the Johns Hopkins Applied Physics Research Lab. No, Applied Physics Lab.
Yes.
APL, JPL. I'll get it right one day. Kate, thanks so much for being on the show.
Thanks for having me.
Well, listen, I've got this big question. Getting great content this morning, but one of the things NASA was really clear about with this mission, that it was a habitability study, not a life detection mission. I'm not going to say that I was clamoring for a life detection mission or not, but both are great questions. But what's the difference between a habitability survey and life detection, and how do you determine that scientifically?
Right. So the habitability question really has to do with assessing the environment at Europa to understand, does it have all the ingredients that we think life as we know it needs to exist? And so several of those are, we need a liquid that life, the chemistry, things can mix together within. And we need energy that life can draw from, and we need ingredients that life can live off of. And we also need time, which we don't really know yet how much time life needs to sort of take hold and further evolve in an environment. But we know Europa's ocean's been around for billions of years, and so we really think it has the time there that is needed. Yes.
Well, yeah, if it does, perfectly, right?
Yes.
It does. It has that. But then you mentioned these other categories. How do you assess those from a spacecraft from Earth?
Right, and so that's why NASA really thought that we needed a flagship level mission to assess this really all-encompassing question, because we needed multiple different types of investigations. So we have 10 investigations on Europa Clipper, and so pulling all of that fantastic science together will be what will help us assess whether Europa's environment is a habitable one.
And so, again, back to this question of habitability, if you determine that all those things are true, what's the result? That maybe either one day it did, or maybe one day it could? How does that work?
Right, or even potentially today it is,
sure.
right, habitable. And so that's what we're hoping to determine with Europa Clipper. And then a follow-on mission would hopefully land, sample the near-surface ice, even possibly penetrate down into the ice shell, maybe reaching near-surface water pockets, which we hope exist at Europa, and be able to sample the liquid, or very recently liquid material that might have come from the ocean towards the surface, and give us evidence of biosignatures and potential for the life to be there now.
Okay, I know this isn't in your wheelhouse, but is there any way we can put some boosters on it and get it there quicker? Because I really want to get the data, as I'm sure you do.
I know. We're all, it is very hard with these outer planet missions. We do have to have patience, but we do lots of things while we're sort of waiting to arrive at Jupiter. We'll be doing field work and lab work, also looking at JWST and HST, Hubble Space Telescope observations, looking for signs of recent or even today activity that could further inform us about what we would want to look for when we arrive at Europa.
That's awesome. And of course, the partnership between NASA and APL has been great. We've had multiple missions previously, more to come, but you guys put some instruments on this spacecraft.
Yes, so for APL, we built 2 of the instruments, the ICE cameras and the plasma instrument, as well as parts of the MISE infrared spectrometer. And so we built that, as well as the propulsion module and the RF frequency module that all the instruments and everything are going on to. I built that, did some testing at Goddard, and then sent it out to JPL for further integration of all the instruments and further testing now to JPL.
I love it. I could never work at APL because I'm not qualified, but I would love to. I would love to, and I love seeing what you guys are doing together. Great partnership, great mission. Thanks so much, Kate, for being on the show.
Thanks so much for having me, and go Europa Clipper.
Absolutely. Well, I tell you what, I gave the impression earlier that Franklin was still in conversation with Kobe. While that's not true. He's actually here in Florida and ready to give us an update on the status of the rocket. Franklin, how are things with you and Mick Woltman there?
Hey, Blair. Yeah, it's doing great. It's a really sunny day out here on the coast. But joining me is Mick Woltman from NASA's Launch Services Program, and behind us is the historic Launch Pad 39A, where just last night, SpaceX's Falcon Heavy was lifted into the vertical position in preparation for tomorrow's scheduled launch of Europa Clipper. Good morning, Mick.
Good morning, Franklin. Glad to be here. Glad to join you guys today.
Yes, it's a beautiful day today, but the elephant in the room has been the weather here in Florida. Tell me, how did Hurricane Milton impact the preparation and scheduling of the Europa Clipper launch?
Yeah, Europa Clipper was originally scheduled to launch October 10th. However, due to Hurricane Milton, the team had to secure Launch Complex 39 and the hangar where the launch vehicle and the spacecraft were stored. The launch team did an amazing job of securing everything, followed all their hurricane prep procedures, and they made sure that the spacecraft still had its environmental control and power. They remotely monitored all that, so thank goodness for technology. We were able to continue to do all that, but they did an amazing job of looking at it. There was some minor damage to the pad, but that was fixed easy, and the team moved on, and we'll be moving into launch readiness review later this afternoon, getting ready for a launch tomorrow at 12:05.
Now, we're in Florida. There's always weather, but how often do you deal with a hurricane, and how have you managed it in the past?
Yeah, it's very rare that we get hurricane-type storms here at Kennedy Space Center. However, we have had some over the 26 years actually that LSP's been in existence, and we've had to deal with that on some missions like Pluto New Horizons, where a hurricane came through when we had the vehicle at the pad, a couple other missions that we've worked. But the team has procedures in place to make sure that they can batten down the hatches, if you will, and make sure everything is secure the launch vehicle. And our most important thing is to make sure the spacecraft is safe. And the team did a great job with Europa Clipper on that, working with the JPL team to make sure Europa Clipper was maintained through the storm and getting ready for launch tomorrow.
Now that it's vertical, what is the status of the Falcon Heavy and Europa Clipper as we look for tomorrow's launch?
Yeah, everything is looking great. The team has finished up all their assessments, done all the work they need to do. As I said, we're going to have launch readiness review this afternoon, where NASA's launch manager, Tim Dunn, will poll the team and make sure we are ready to move into terminal count for tomorrow and get ready for propellant loading at T-minus 50 minutes prior to launch. So everything's looking good. I can't say enough about JPL, LSP, SpaceX, and the U.S. Space Force, the collaboration between all the teams and partners to get us to this point, especially through Hurricane Milton and everything we've had to work through.
Now, looking at the Falcon Heavy, there are two used first stages on there. Is there any special story behind them? Yeah,
the Falcon Heavy basically is 3 Falcon 9s, right? But the 2 side boosters for Europa Clipper are what we call previously flown boosters. Boosters 10, 64, and 65 were actually used by Launch Services Program on the Psyche mission, which launched a year ago today, actually, October 13th, 2023. And it was the 4th mission that we used those boosters on during Psyche. Europa Clipper will be the 6th. Between that, the Space Force used them on one of their missions. But we will be expending all 3 vehicles, so we won't be bringing anything back today or tomorrow from the mission. If you look at them very closely, the landing legs have been removed, the grid fins have been removed. SpaceX has done an amazing job to reduce the weight of the rocket so that we can get every bit of performance out of all 27 engines and the Falcon Heavy for Europa Clipper. Being one of the largest planetary missions that NASA has launched, we need all that performance to get us on its way for a successful mission.
Because this is one of the largest planetary mission that NASA has ever launched, did LSP have to go through any special considerations working with SpaceX to ensure that you could get this satellite into space?
Yeah, absolutely. As I said, we reduced the weight of the rocket. That was one of the big things. But then there were some mission unique things that had to be done. Planetary protection to make sure that the spacecraft was protected from different things. We'll be flying through the radiation belt, so things that had to be done there. Different trajectory analysis that had to be done. Our analysis group working alongside SpaceX developed this trajectory so that we get this Earth assist and getting on to Europa for its study. So the team did an amazing job of coming up with this mission trajectory and mission solution to make sure we could get Europa Clipper on its way. So again, can't say enough about how well this team has worked over the last several years to get to tomorrow's launch attempt.
Mick, now, Launch Services Program is doing, managing launches all the time. What's coming up in the future for LSP?
Yeah, so Europa Clipper is our big focus for tomorrow, but right after Europa Clipper, we've got SphereX Punch out of Vandenberg Space Force Base in 2025, February, March of 2025. We're looking forward to that. As always, we're working anywhere from 50 to 60 missions. SphereX Punch is our next one on the docket for launch. but we continue to work with other missions that'll be down the road. The team at LSP, continuing to work with our commercial partners, is just amazing, the things that we do for NASA as an agency and the scientific and robotic missions that we launch. We're just very excited about the science and the things we can do to help the agency.
Well, Mick, thank you for being on the show with us today, and you'll be on launch coverage tomorrow?
Yes, I will. I'll be commentating the launch with Daryl Nail. We look forward to liftoff at 12:05.
There you have it. Make sure you follow NASA Plus on all of our digital channels as we continue the coverage of the Europa Clipper launch. We'll see you tomorrow.